here at functional conference, I mostly attend functional conferences. Although it's true, actually, my experience is mostly Java, Spring. Who actually worked with Java and Java E or Spring? Yeah, great. Yeah, I know how you suffer every day. I always dreamed about the moment I saw functional programming. Actually, that was even before Java, but my first thing was that was in '90s. There was a language SML, which is now close to OCaml, a little bit like ancient OCaml to some extent. But basically, I thought this is awesome, but it will never be on a production. And 25 years later, actually we have it on production. So that's great. I love it. So, by the way, who loves Haskell here? Yeah, that's a language it's easy to love it. Yeah, it's like who loves JavaScript? Great. I actually have some love-hate relation with JavaScript. It's not. I actually don't disregard JavaScript. I made a presentation about JavaScript in the past that is actually what people expect. Okay, but that's about me. My company, Digital Asset, we basically that's. Why is this talk? This is about Daml, basically a product we create. But I'm not a marketing guy, I'm a software engineer, so if you want to know more job opportunities in Switzerland or even remotely, go to this page, you will find our products, information, documentation, everything. I'm here to talk about Daml. So, but what I will be talking about is, I start with a smart contracts. So I try to give you, if you don't know what a smart contract is, I bet most of you know, but my opinion on that, then about Daml, and then actually this talk should be relatively light, I will show you how we make applications that actually work on Haskell easily with some persistence and with some UI. Actually, you can use different languages. I will show kind of a mix when there will be a TypeScript, Scala, and Daml. What is Daml? You will see. And so first, let's talk about smart contracts. Who know what a smart contract is? Great. Okay, maybe you. Sorry, your name is? Tomasz. Oh, Tomasz, okay. Can you explain to me? Sorry.
Smart contract is a program that is executed in the blockchain context.
Okay.
Sorry. Smart contract is a program that is executed in a blockchain context. And I don't know, I guess it accepts events and produces a set of produces a new state for a contract, I guess.
Okay. I love this definition. That's actually, yeah, I agree. That's one of the definitions. I will try to show you mine, but I thank you for that. You actually saved me a lot of time. You did my job great. I never know how to actually explain smart contracts. I will try to show you with pictures. So first, why would we need smart contracts? So if you are here, you think this digital asset is probably another blockchain something company and will do this typical, NFT, crypto scam, whatever. No, we don't do anything with, our target are not cryptocurrencies. Our target is blockchain. Blockchain as a technology to exchange information. And this is like our case. We have some institutions, some financial institutions, but not only, for instance, can be a medical, whatever. There is a bank that's in New York. There is a stock exchange that is in Singapore, and then there is investment fund that's in Frankfurt, maybe. And they want to share some information, maybe trade, maybe exchange information about something. How are they gonna do that? So maybe, well, I don't know, this investment fund they will be creating API. Architects will meet together. They will design API. They will have a database, and after 3 years of setting agreements, they will finally be able to trade something, and there will be API. Of course, bank will implement this API only 10 years later. I work for banks, so I know what will happen. That will be kind of a slow. That's how things are still working. They are slow, and on the market, being slow is not that great. So they need some kind of a platforms that they can relatively quickly introduce new types of data exchange. Really data, not really money always, but quite often just data. And for instance, even if they have some maybe platform who has a database, if there is like database, I don't know, maybe in Singapore, what if there is like hardware failure and database is lost and they tell, backup was in the same place as, original data, so sorry, it's gone. And now, for instance, customers' data are gone. You don't know really the contracts you had. Everyone is somehow affected. And people are actually companies go bankrupt. Legal system change, so someone can be malicious, can turn malicious. Many things when you centralize a database. So companies obviously long ago found out the technology that allows you to decentralize data, so that the data is somehow spread, and it can, if something fails, we don't lose, and everyone more or less, for instance, if there is disagreement, we can prove that was, for instance, order you set. And that's basically a blockchain idea. And so what is the blockchain more? Like, the digital signature? Yeah, whenever there is a problem in internet, we now have digital signature. As long as something is signed by your signature, I will not explain how it works. We know that basically is signed, and in case of a legal problem, you can present, oh, sorry, this partner signed this document. Yeah, maybe his key was stolen, but that's a different story, but then it's also a problem. But what is this? I like to look at the smart contracts as when you digitally sign a document, it's a static document that is signed. But think about signing a running machine with a code. That's more or less how I look at smart contracts. So it's like just improvement. It's like dynamic digital signature, because everyone can prove this happened in this order, and that's it. So basically, smart contract, you have some rules for this machine, how it works. And it's like basically signed. If you change these rules, they actually sometimes change. There is a process, and everyone is signing. Like, there is a code, and whenever code lands there, it's basically signed. So we know this code comes from this person, and it's, let's say, valid. I want these rules working. Then we have input, which is basically sign. You do something, you must sign. I did this transaction, I ordered this, whatever. This can be data, and actions more or less input. So that's how I look at it, smart contracts. And important part of this that you can typically dynamically create new smart contracts. So there is this engine on the blockchain running, and you can give new smart contracts. And obviously right now, probably the most popular, and I don't think anyone doubts about it, but Ethereum. And this is actually a great platform if you're a developer. It is really interesting from a mathematical point of view. They also solved a little bit environmental issues last year. So this is, and there's only a few small problems with Ethereum. First, the language, Solidity. Who has ever worked with Solidity? Do you love it? Yeah, so when actually I had experience with C multiple years before Java. That was mostly on the university, on hobby projects, but I have experience with C. I have experience with JS. And Solidity for me is like a mix of worst features of both. It's like every line is a trap. Every line, something can go wrong. You have to be very careful, look at those lines, and there are newsletters I actually followed for some time when I was doing something with Ethereum. But every week something happens. Someone just posts a contract in Ethereum, makes a small mistake, and this is language like it's begging you to make a mistake. And it was money. And sometimes the worst part of that is the worst. Actually, this kind of beauty. You put a contract, and it's there forever. So if you made a mistake, does this contract just let other people take your money? They will take it, and there's nothing you can do. Maybe you can try to be first to take this money back, but typically you will lose. Because there are machines actually in Ethereum, I don't know if you're forerunners, there are machines that are really close and fast that try to find automatically all these holes and will do this transaction faster than you. So you make a mistake, you instantly almost lose your money, and there's nothing you can do. And then sometimes there were people looking that they made a mistake, and this is possible to maybe get this money back, and they had they were fighting for a day or two, never were faster, because actually how Ethereum works, if you find out how to get this money back, how to get error, the machines scan also this, that someone is trying to get money back and correcting error. And will do that transaction on their own still. This is really beauty. But, so that's the problem that people try to address. Maybe there should be a safer language. functional programming with types is solving some of these issues. And there are more problems with Ethereum, like for enterprises, you know, if all the money that company, for instance, has is on Ethereum, on the mainnet. If someone takes the private key, and you know, some may have access to this private key somewhere, then this person can just go, I don't know, somewhere to country which doesn't have a proper legal system and can do everything in the name of the company. So private key gets stolen, the company, for instance, big bank, is screwed, basically. So, yeah, that's not so great, and that's how more or less, I don't know really the story behind. I wasn't originally in the tip. I actually joined the company quite recently, like 2 years ago. So I don't know all the behind story of Daml, but when I read Daml, I instantly thought of it, oh, that solves exactly these issues. Like safer smart contract language. And yeah. What's more interesting, it actually can run, okay, so it can run with Ethereum using Ethereum as a storage, as a ledger. So ledger, basically, I'm using if you place as ledger, I don't want to explain, it's like, it's from accounting, but basically, think of a database, also a blockchain. That's a ledger, actually. So the source of truth. So what is a Daml? This is a language, which is open source, and Haskell, but asterisk syntax. So basically, who knows Haskell? Yeah, so if you know Haskell, you know Daml, basically. The most parts of the code you will understand, because that looks like a Haskell and has, what are differences? So actually this is a fork of GHC. We will see how beautiful is that a little bit later. Has some limitations. There are some about how you create data, but really you learn it quickly and you don't encounter them. So typically you want to write an algorithm, you can copy from Hackish or whatever and put it. So, very important thing why you might not like to call it Haskell, because it's strict. So it doesn't use lazy evaluation for reasons. It's a strict language. So yeah, that tells, okay, it's not really Haskell. Okay, it's just Haskell syntax, but it's still great. And that makes a big difference. We have totally different prelude because it works on this machine, so it's very limited what you can do. You cannot load the file from the disk, ask internet. All that things are basically gone. You can only do things allowed on this machine as a smart contract. And the big point of Daml is it will try to keep you safe, so that the possibility that you make an error, or for instance do a contract that will cause you losing money or something, is small, because it's like if a Haskell is a language that requires for you to prove the compiler that you are right, Daml on top of that brings the proof that your contract is not stupid, more or less. And we will see that. So you can think of Daml when you do applications. We do applications with Daml. It's typically, Daml is something that works, let's say, in a blockchain contract with context, so like exactly smart contract. But you can think of as a stored procedure. Who works with stored procedures? Yeah, so it's the same thing. You just have database, you call this function, give me the results. That's how, if you build application, you basically define domain logic. I know that probably saying my domain logic is in stored procedure doesn't sound nice. Because probably who has business logic in stored procedures in the past? Yeah, and did you love it? Mostly probably not, because that was PL/SQL or Transact SQL, beautiful languages. But what if that was a Haskell, at least looking like Haskell? That would be a little bit different story probably. And yeah, so more interesting part, actually you can even run it on a single database and, for instance, on top of Postgres, and think of it, this is just my business logic in Daml, and that's just application that's totally not connected to any, let's say, real blockchain. The blockchain is my single database, so that's not really a distributed ledger. That's just single machine. Yeah.
So just to clarify, Daml actually currently already supports using a SQL database in that, right?
So for sure it supports Postgres. With other databases, it's I don't fully know.
Okay.
So, okay. So, who recognizes this? Yeah, the beauty of Haskell, who loves this? Having a different set of... so, this is just from a real project in Daml. It's just, yeah, we used out of that. So this is like GHC extension to Haskell supported by GHC. And basically, any you would need already there. Some are like built in actually. For instance, better record syntax was in Daml before it was actually in GHC. And so, as I said, because that's not a surprise, because again, basically, Daml is based on fork of GHC. So there is like fork, and we actually, at some point, there are those compilation phases in Haskell, and we just take over this where this is generated. I forgot which phase. And one phase we basically, stop generating code, maybe, I don't know, C minus, minus, or minus, minus, or core, whatever, core, probably, and we just generate our code, which is basically to be interpreted to run in a blockchain context. But I forgot the details because we mostly never see that. We actually never see that. How you work with that? That's really easy. You install Daml, there is a web page, there is a command line that you install. We support nicks and things like that. And then you use this to create small demo. Automatically will be created for you, demo that works. And then you get a profit, obviously, like 0.3, always the most important. You can see how it works. And I tell you at the end, why would you even like to do that? So, obviously, there is a documentation. We are constantly working with our documentation. And I would say, we always find something doesn't work, but this company invests a lot of money in having decent documentation, and even though we are always blaming something isn't great, we're trying to make it perfect. That will probably never happen, but I can tell you that I follow this documentation regularly, and basically things work. For instance, Daml inside of Kubernetes, all of that stuff we have documented, how to run in Docker, etc., etc. All that stuff is documented. There are links to forums. For instance, as me, as an employee of digital asset, if I have a problem with Daml, I actually have to ask public forum, and you will find my questions. And that's how we even build like knowledge, because all the problems that we even have internally are answered by other colleagues and visible to public. Okay, so let's build something. I will not show you a demo that's ready, because that would be boring. I will show you some game. And we'll try to play, obviously that's demo, so the chances that works are small, but we'll try anyhow. So you know the game that's called Crocodile, maybe? I am very good at this game, first. I will demonstrate you a game, so Ida. Tell me a number.
7.
8. Mine is bigger. I won. This is the Crocodile game. So, Kamil, you'll try. Tell a number.
100.
102. As you see, I won. I'm extremely good at this game. You can't beat me. Basically, I'm 1,020,000. You see, that's like impossible. Like, but you know, I will give you a chance. We'll modify this game to give you a chance. Right? Just slight, maybe you will have a chance. We'll modify the game that many people will play this. Secretly will give a number, and not the biggest wins, the second biggest. Is that more interesting? Like, you have to guess the second biggest number. Like, now let's try it. So, you can scan this barcode or go to this web page. If too many of you joined, we'll kill the server, but don't worry, we'll pretend it works. And we'll try. So basically, try to log in. Okay, sorry. You have to log in and give a number. Sorry, UI is not great, but you know I am engineer, backend engineer, so even if I do something with React and TypeScript, it still looks like a Java developer has created it. Does it work somehow? Nope. Oh, we'll see. Okay, then we'll pretend it works, okay? So this is me going to the page, giving a, for instance, let me call myself Adrian. That's not my name, but that's a great name. And yeah, and now I have to put here a number. So you just pretend you haven't seen it. and I do this. Yeah, and now I wait. So who had more or less this result? Now, who can get to this point? Yeah, few of you. Now we play. How we play? We wait. So, because how it works for 30 seconds when no one is giving new bets. So maybe stop now if you didn't manage, we'll see, because otherwise we'll never see the result if new people are coming. Sorry, now a little bit of patience. And by the way, my connection in the meantime to server that shows where we are has broke, so we will have to just guess. If it does, nothing appears for a few, in a 1 minute, we'll pretend it worked. But maybe you should see something.
Can you make the fonts like obnoxiously big?
Yeah.
Even more obnoxious. oh, that was good. That's a
Is there a length limit for the input field?
I totally, so if you give too big, it will just fail. Sorry.
Yeah, that's what I expect.
I don't know. I forgot the limit.
That's the most important.
Sorry, I'm backend engineer. If you made a wrong number, that's your fault. Sorry. you already lost. Sorry. So, it seems to be somehow working long. Just let me check. Let's pretend. That's the internet connection. There are plenty of proposals actually. So something should. Oh no, it means it's not working. Oh, you know what? We'll start to work with that. It means that something failed because it's not supposed to be here. But now we'll have live repairing of that. Something failed. I don't know why, but I'm partially prepared for that. You never are fully prepared, but. Hope I know what. Okay, I never experienced that. Obviously, during the normal work it never happens. But SBT. I will learn. Okay, first, now Java development magic. What do we have here? It should be working. Let's numbers game log, and we'll see. But you know what? What happens? We'll kill some stuff. Sorry. Kill this as well. Sorry, that's. We can pretend it worked, but let's maybe rescue that. Which could be that we'll rescue that. I actually kind of love when stuff fails because that's always interesting lesson. Oh, there is no such. Oh, so maybe it's already great. Okay, SBT, run. Who knows what SBT is? And we'll see. If it doesn't work, then we'll forget about it. And I will tell you how it's supposed to work. See. Okay. Then, actually that's... concurrent. Okay, sorry for that, but that probably will not work. And you know what? I could technically run this game without Scala part. Connection diffused. I don't know how can we. Okay. No, and at this point I cannot rescue that. I just check if the connection is there. Maybe because of the internet connection something broke. 6.8, yeah.
Maybe you need to reboot the server.
We would have to, yeah. Actually, one piece doesn't work. JPS, one piece doesn't work. I know. Now it's my fault. We'll try to restart this game, okay? That will be maybe funny or not, but we'll have everything in. Actually, the connection now works better, but I had to kill the data. Actually, I did it by killing one of the process, and I made it not persistent. But we'll rescue that. Okay. So CRT new window, SSH. Sorry for that. It happens. Okay. So just check if this works. Oh, this is maybe that was too slowly working. So now we get to the question if UI works. Actually, kind of works, seems so.
Complaints on invalid JSON.
On what?
Invalid JSON when you put anything.
Because the server was just starting. I killed everything, and sorry, I know in one moment I killed too many processes. No one that was a database, but okay, this happens. Like if you, I forgot that it actually presents itself as a Java code. So yeah, happens. We'll try again. If you still have, we have some time. I actually somehow calculated that this can happen, live demo, and now I have to do SBT run, and we'll see if it works now. Yeah, there's applause already. That's like, quick. Maybe I didn't kill, okay. It's actually, okay. We have some people playing. Are you playing right now? Yeah, so we have some. So please, put some numbers, and now we have actually the output, so if something fails, we'll see. Basically, it restarts as long as everyone joins. So you have to stop doing that, because we need this to get to 30. But oh, come on, we'll do it, don't worry. Obviously, that's a great game. You never know when it finishes. You can keep it constant. I can continue with the presentation, but let's give it a chance. If no one joins in the next second, maybe bots are now joining this game, then we should have some result. And you should see that on your screen. A little bit. So watch this carefully. Someone will win. No, we're almost there. Maybe there will be an error, I don't know. Maybe I made an error I've never seen yet. Wow. So someone had won, and I don't see here in the log.
It says we just won, congratulations. Doesn't mean I won.
Which number you got?
Many nines and then a 4.
So someone gave all the nines. So congratulations! We have a winner! So this is a really funny game to play.
What do I get?
You got a handshake.
Can I get a hug?
Sorry?
Can I get a hug instead?
Yeah, obviously. Great. That was awesome. So we continue, you see, Daml never fails. Okay, sometimes, actually, I am a Scala developer, and I know that I'm not the greatest Scala developer in the world, and something happened. Well, I will analyze later. So this is how it works. Now how you code it. So what you can do, I will try to do this, is just maybe this screen. Any moment, I will just kill it because I don't need it anymore. Any moment you can go to the code. There is a demo actually created for you. Numbers game, a moment. Maybe it's called here. Okay, I forgot where is my folder. Canton. Okay, Daml numbers game. If you have Visual Studio Code, you actually have this. There is a support so as I said, we actually invest in tools and developer experience. So your experience should be typically better when with other languages. So you actually have something that works. I will show later how it works, but basically the syntax is supported, and you can even see and test the code here and see the blockchain, more or less how it works. I will demonstrate that later, but that's honestly, I am IntelliJ developer, I know. I tried Emacs sometimes when I hate IntelliJ. I don't like Visual Studio Code because I don't know why. But from IntelliJ just works as well. With basically you have Haskell syntax, then you have Daml syntax support. And it's just not as nice as Visual Studio is, but it's still good enough. Okay, so how we actually code this? So who understands this? Yeah, that's a Haskell. You see the difference. I told you the prelude is different. So we don't have typical Haskell list. We have something called DA list. And you have these DA packages which basically cover things like maybe, which by the way here is called optional, but for some reason. And so there are small changes. Some changes are because this is a strict language, as I said. So basically, but most importantly, you have just limited set of operations that you can do on a blockchain. So not everything, as I said, I/O, for instance, is not possible here directly, and that's how you model your data. So we start with data modeling. That's a bet. Player, which is called party, that's built-in type, and which integer. And we have even deriving, all that things work, as you see. Then we code our business logic, second best. If we have a list of bets, for list, empty list, then the result is none. For a single bet, actually we have some bet because there was only one player. By the way, here in the game, at least 3 players are needed, but that's actually part which is in Scala. But technically, this game from a Daml model is, as long as we have 1 player, it can be solved. Then we just sort it in maybe this way, or we'll use order instance. We can do that. All that, if you know Haskell, works. So basically, having Haskell experience, playing with Daml is relatively easy. You have to understand that you don't have exactly the same base, but that's it. Now comes the moment of when things go differently. So this is a template. What is a template? It's basically your smart contract. And smart contract starts with a data. So proposal, it's when you were sending this bet, you were saying, I'm this player, and for instance, Jarek, I give this number int, and a dealer. Who is a dealer? It's basically, to make it working, the easiest thing is to designate a player that is coordinating all of that. Why? Because now comes important part. Signatory, that's important. Who has signed this contract? So when you create this contract, someone must sign it. This is mine. I created this data. It's on a ledger. I am responsible for what's happened here. But then no one actually, apart from you, sees this data. It's just as if it was not there. You are not part of this deal. You don't see it. And even if this lands on Ethereum, that's actually the privacy guarantee that we have. No one that's not a part of the contract will see that. But we actually, who is the part of the contract? Signatory, the one that's signed, and we can designate, that's a special keyword, a dealer, so someone that can see that. So there is a player here called admin that will see all your proposal and will be able to read for them. And that will be this. So we start from that. By the way, what happens actually, there is this compiler. Why do we even do that? Technically, there is like a phase in compilation which changes this to some regular Haskell. But we do that because on this level we can have additional safety guarantees. What can happen, who can sign, etc. That's what Daml. So Daml will try to guide you, if you write these templates, to not do something stupid. For instance, to sign something that you haven't seen. At least you should have access to the data you sign, for instance. Then there is a game. So that's another contract. So you can think of these contracts like a tables in database. The game is a table, and we will have instance of a game. Mostly there will be like one instance of the game because it's like assigned to dealer. So this will be effectively a singleton, but it's not visible from this contract. So we have signatory, a dealer, admin, that would be normally. And now comes interesting part, a choice. What is a choice? It's like a method, like a function that works on the contract. And now a very important part. If you do this choice, the contract will be deleted. It's always like that. If you do something with instance of contract, like instance of game, this will be consumed. We call it consumed. It's actually saved, but it's not there anymore. It's not active anymore. This is very important, actually, in safety, because, for instance, you can't do double spending, like twice get the money from the contract. Accidentally, nothing like this is possible. So, and what's written here, that's a function called append, method called append, that will result with a contract ID game. What it means, there will be new game created. So we take a game as it is now, with, for instance, 10 dealer and 10 bets from 10 players. And what we do, controller is dealer who is doing that, who will sign effectively this. And then there will be new game signed by this dealer when there is just new bet added this way. That's how we play with lists in Haskell. So basically we consume existing, yeah? Yeah, question?
5 minutes.
5 minutes, okay, sorry. So now And that would be easy, but let's make things complex. Because what we had, you remember this proposal. There's one problem. So if there is this proposal and we add it to game, this proposal still stays. So why not it second time or third time? Maybe you will pay to. So we have to somehow consume this proposal. So there are templates, on our page I'll read the patterns, how you deal with that. Actually, you have on proposal, you give another method, so before we didn't have it, which is called accept, which will consume this proposal, so it will disappear. But the dealer basically have a proposal because I searched it in the database, basically in this Daml database, Daml ledger. Now I do accept, and inside this accept, what we do actually, we call append method that we just seen choice on a game. So it's basically we do two things at once. We consume proposal and we add it to the game, and that's how we get a new state of the game. Proposal is gone. And that's the end, the result. So result is basically who was the winner, won all the bets, just to check it, didn't have to be there. You can, for instance, that field is, let's say, I made it to make it visible what was the bets, but maybe you can want to hide it. At this moment, you don't need it. Observer, as you see, this is actually an expression. All the players, participants of this, will be able to see the results. So now you know who won, who lost. Yeah? And signature, that's still a dealer signing all of that running. Okay, and basically the result we get when we consume game and put this decide. And that's it. How we test that? There is a command Daml test that runs your test. That's how your tests are written. For instance, we do like, I write the full, this is a script, we have something, this is for tests. Basically, we simulate all this ledger in tests, and even more funny, for instance, and I would like to show you that, in Visual Studio Code, we can run it and see all the stages that happened. Like, for instance, there were those proposals. Sorry, this font is a little bit small here, but you will see that all the proposal at the end of the test are basically gone. So they were at one stage valid, but they're gone. If I here comment out code, I will see the different thing, but I want to do something else. So, and that's the result. Everything was consumed and we stayed. Think of it as just the database. But now I will show something. Okay, I cannot make this font bigger. I haven't predicted it. I will do one funny thing. Here is a Bob proposal. I will make this font. Okay, sorry, Visual Studio, I forgot. So here is a Bob proposing something, but I do something malicious. I say, it's not Bob, Bob will be doing a proposal, but he will say, I'm Alice. So he would like to make a proposal. He sends a proposal, but says, I'm someone different. So it's trying to do something malicious. What will happen? It actually breaks, you see here an error, and you have the different states. So it like instantly works and validates your scenarios. And basically you just see one of the features of Daml, it will keep you safe. If you do something like this will not be prevented. How you build UI? Basically we have great JSON API generated, so you have actually TypeScript object, and so you see ledger create proposal, that's actually our object from Daml. If you do Daml start, it will be generated. This is optional, but by default we have enabled. And then we await with proposal, etc. Scala part, we generate code in Java. And then we can connect to that. Here's a little bit complex code, because actually this is very simple. You just use Rx Java. I wanted to show you who used Scala and Zio. Yeah. I wanted to show how, for instance, change this Rx Java events into Z-stream. It's a little bit of code, but that's not complex, and it's my example. And basically you have, again, because code is generated, you can just do everything. So basically, I used Scala part to be kind of a dealer who knows when and what done. It doesn't have to be there, but I made it just to show. Then we have something like Navigator. It's automatically kind of a browser for your database. And with Navigator, maybe I will be able to okay, I won't show you that, but basically you can see all the contracts as a person. This is like great if you're just playing with that. It means you can write your model in Daml and do everything without writing any Scala code or JavaScript UI. This is your like kind of as if you were doing things on a database directly. Then working with Postgres, as I said, you can maybe just want to build application model something in Haskell here in Daml, and then have just application internet. Maybe you want a real persistent because that by default it works with in-memory, so you can connect it to the Postgres. And that's how you have really working application written in Haskell. Of course, front-end can be in pure script, you can do that. Backend can be in Haskell, whatever. What we provide for our customers at the end is, for instance, this picture shows something like Canton Network, where, for instance, there is a piece of code in Daml, and it works, for instance, for one customer, the data is stored on Ethereum, for SQL, for instance, in Fabric, and they are connected, they even can exchange the data, and we have support for consensus and everything. One thing, where company gets money, if you do for real Ethereum or for real Fabric, you actually pay for that. If you go for Postgres, just free. And why? The most important question, why? Because you want to learn the smart contracts. I know that crypto is a little bit, crazy thing, but smart contracts are just for a real business, and it's nothing, and it's very interesting from mathematical point of view, and Daml is a thing that will guide you, that will show you, and maybe then we will learn Daml and we'll know how to say for right thing in Solidity. That's, for instance, one of the ideas. You just be guided how should we have tons of patterns, how you do stuff, how you exchange tokens safely between parties. That's on our page. So if we have packages that will do that for you, library, how to safely exchange tokens between parties. Because it seems like easy thing, but it's like multiple steps. Even if it's on Solidity, it's actually quite complex process. You want to do some demo proof of concept for your model, like you design something. You want to show that this makes sense as a domain. You can use Daml. And want to conquer the world, build application, you can use Daml for that. Hopefully one day we'll have to go to Ethereum and pay a little bit. But okay, if you want to see the code, it's on my GitHub, Daml numbers game. Basically way more is on the documentation, and now it's time for questions. Sorry.
Thank you, Jarek.